This is a problem using Bayes' theorem and conditional probability. A local bank reviewed its credit card policy with the intention of recalling some of its credit cards. In the past, approximately 5% of the cardholders defaulted, leaving the bank unable to collect the outstanding balance. Hence, management established a prior probability of 0.05 that any particular cardholder will default. So now we know now we know probability of default is 0.05. The bank also found the probability of missing a monthly payment is 0.20 for customers who do not default. So probability given that the customer does not default, D bar does not default, the probability of missing a payment is 0.2. Of course, the probability of missing a monthly payment for those who default is 1. So of course we know probability given that you default, of course you must have also missed a payment, so that is 1. Given that a customer missed one or more monthly payments, compute the posterior probability that the customer will default. So we're looking for probability that given somebody missed the payment, what is the probability that the individual will default? That is what we're looking for. So we're going to answer part A now, and the way we can do it is by using tree diagramming. Of course, we know to compute this, if we know the probability of D intersect M, and if we divide that probability of M, then we have our answer. This is from Bayes' theorem and from conditional probability. But let's go ahead and, in order to compute these two entries right here, let's go ahead and use our tree diagramming approach that I've shown you before in some of the previous videos. Let's start, because we have the prior probability of an event, which would be default. Let's go ahead and diagram that first. So we branch out with that. And if we know that is 0.05, then the probability of not defaulting is a complement, which is 0.95. We also know the probabilities of M given D. So this would be M given D. Given that somebody has defaulted, the probability of missing a payment we know is 1. And the probability of this would be not missing a payment, again given default, would have to be 0. Those are complementary to each other. And we also know probability of M given D bar from the statement of the problem. That's the 0.2 that was given to us. And so M bar given D bar will have to be 0.8. We also know that the joint probabilities can be written here. All of these are probabilities that I've put on here, and I just haven't put the P parentheses on them, but these are all probabilities. And so we know probability of M and D can be computed by taking 0.05, multiplying it by 1, which will give us 0.05. This one will be probability of D and M bar, not missing a payment, probability of D and M bar, and that would be 0.05 times 0, which is 0. This other one will be in the bottom branch right here, and then right here is the probability of M and D bar, and that would be 0.95 times 0.2, which is 0.19. And this last one is going to be probability of M bar and D bar, and that would be 0.95 multiplied by 0.8, which gives us 0.76. And of course we know all of these have to add up to 1. Now from here I'm able to figure out what the answer is. this right here, probability of m, I can compute it by this number, add it up to this number, because those are the two events that have, actually maybe I shouldn't, those are the two events that have the m event in them. The two joint probabilities of 0.05 and 0.19 give us the probability of m, which of course we know it would be 0.19 plus 0.05 would be 0.24, and probability of m and d, or m intersect d, is given right here. Oops, maybe I didn't want to highlight. I wanted to use the red pen. That probability is right here, which is this one, and that's 0.05. And so if I take 0.05 and divide it by 0.24, I have my answer, which is 0.2083. But let's go ahead and go through the tree flipping, just so that you can, for those of you who can't see that relationship, you can always do the tree flipping. We now, by flipping the tree, we now start with the events m and m bar, and we branch out to probability of d given m, probability of d bar given m, and these ones will be probability of m bar, I'm sorry, probability of d given m bar, and probability of d bar given m bar. And we know that these end probabilities, or joint probabilities to go at the end, are going to be probability, looking at the events here, are probability of d and m. This one is probability of m and d bar. This is probability of d and m bar. And this is probability of d bar and m bar. And now we can see those. We should start our analysis from the end, from the back of the tree right here, and work it to the front of the tree, which would be right here. So d and m is over here, and that would be this probability, so I'll transfer it over here. M and d bar is right here, so I will put it right here. D and m bar, oops, let me get this out there. D and m bar is 0, so I will put the 0 here, and d bar m bar is this 0.76, and I'll put it over here. Now we know, as I've told you before, the end probabilities, or the joint probabilities of the two branches up here, 0.05 and 0, of course, give us this number, which is the prior probability of this event right here, and the 0.19 and the 0.76 at the end of the bottom branches right here add up to this number. So the same rule holds here. These numbers that I will highlight for you, these two, will add up to this number, and these two numbers right here will add up to this number. So all I have to do is add those up and put them here, which would be 0.24 and 0.76. Now, I was looking, if you remember, this was what we were looking for right here. So if I find out what this conditional probability is, then I'll have my answer, which would be 0.05 divided by 0.24, which is exactly what I did right here. So that is the answer, and the probability to, or the answer to question 1 would be 0.2083. And that is, of course, probability of D given M. Default given missed payment. Now the second part says the bank would like to recall its card if the probability that a customer will default is greater than 0.20. Should the bank recall its card if the customer misses a monthly payment? Well, yes, because that probability we computed is 0.2083. The probability that given that somebody missed a payment, the individual will default is 0.2083. And since the bank has a 0.20 as the criterion of decision making, then the bank should recall the card based on their own criterion that they have imposed. Thank you. I hope you have found this helpful.